We have some definitions, different ways of saying what a function is. You can read through those if you like. What I do want to make sure that you understand, though, is oftentimes you're going to see this expression right here written in place of y. You will see f of x. Simply means that it is a function of x. It is function notation. And so f of x is just another name for the dependent variable y. It just gives us another tool that we can use without having to use the variable y. And you will see in just a moment why that is sometimes helpful. It's a useful thing to do. Notice in this example, we have two different equations. The first one does have f of x equals, and then you see the equation. The second one is g of x. See, it doesn't have to be an f in front of the x. If we see a different letter in front of the x that's in parentheses, it allows us to write more than one equation and be able to distinguish the difference between them. Because what we're going to do is go back and plug in some value for x into the correct equation. So, if you look at A, and you are asked to find what f of negative 3 is, we're going to copy the f equation, which is negative x squared minus 6x plus 4. And this simply means everywhere you have an x, you want to plug in negative 3. Now, very carefully, I strongly recommend before you plug in, you need to replace your variable with an open parentheses. And now go back and everywhere you've got that parentheses, stick negative 3 inside. The reason is if you don't do it that way, you are very likely to make a sign mistake. Because now if I'm paying attention to the way this is written, I'm going to notice the next thing that has to be done is I have to square the number negative 3 because that's what x was. That's what's in the parentheses. And if I square negative 3, it gives me a positive 9. But there's still a negative sign in front of that positive 9. That's going to help me in a moment when I clean up. Go to the next one. If I multiply negative 6 times negative 3, I get a positive 18. And then I have a plus 4. Now, if I combine all those terms together, what I end up with is a positive 13. And this is the other thing that's nice about using function notation. When I get to the end, I now can clearly identify one point that is on this graph. It tells me that when x is negative 3, the y value is 13. So there's one point that's on my graph. We're not going to worry about b. All that would indicate is if I wanted to change it to a different variable, I could. All the x's would turn to r's. But look at c, and what you have is a variable expression that you're going to replace for x. So if we go to the g equation, then we're going to plug in r plus 2 everywhere there was an x. So we would see 3, and then in parentheses, we would have the x plus 1. So now when we get ready to replace the x, all we put inside is the r plus 2. Now that means we're going to have to use the distributive property. So this will turn into 3r plus 3 times 2 is 6 plus 1. And we have 3r plus 7 when we combine like terms. This means if we wanted to put it back as an ordered pair, r plus 2 would go with 3r plus 7 as our ordered pair. Let's move to the next page. We have a few more examples. A is simply like what we just did. We would want to plug in negative 1 everywhere we have an x. Again, watch out that you use parentheses and you clean up properly so you don't have sign mistakes. Hopefully you will see after you square -1, that would turn into a +1, and 2 minus 9 would give you a -7. So when x is -1, y would be -7. That's what we get when we evaluate. Notice on B, though, there's no equation. There's just a grouping of ordered pairs. If you're asked to find f of -1, simply means look for the ordered pair where your x value is -1. Your answer is the y that goes with it, 6. That's all you do. If you're looking at C where you have a mapping, follow the arrow. F of -1 would have to equal what? +5. And on D, you may want to enlarge your graph a little bit. It may be a little hard to see, but all I'm going to do is look on the graph where x is -1. It actually occurs right here. Oh, well, it's hard to get my point in the right place with my fat stylus. But f of -1 is actually crossing on the x-axis. So when x is -1, the y value is 0 on the x-axis. And that's the ordered pair -1, 0 on my graph. Now, if I'm given an equation and I'm asked to write it in function notation, there's a couple of steps I have to, be sure to follow. And it's simply this. If the equation is not already written in y equals form, then be sure to solve the equation for y first. If it's not already isolated, then you need to get y by itself. Then you can replace the y with f of x. So that simply means on an example like A, it's already isolated. It says y equals. I simply have to turn it into f of x equals x squared plus 2x minus 3. And if I'm going to evaluate f of -5, I'll put that parentheses everywhere I had an x, and inside I'll come back and plug in -5. After I do that, when I clean up, squaring -5 gives me 25. Do not forget, if you happen to be evaluating this using a calculator, if you don't put the -5 in parentheses before you hit the x squared, your calculator gives you the wrong sign. 2 times -5 is -10, and then you have a -3. If I clean that up, I get 12. When x is -5, y is 12. Now notice on B, the y is not isolated. So we need to get the y by itself. You have some options on how to do this. I'm going to make the recommendation, even though it would be one step shorter, to leave the y term on the left side. If I do that, I'm going to work with more negatives. I would suggest you might consider adding 3y to each side to begin with, and then you're working with positives. Now I will have to turn around and subtract 6 from each side, and that will give me 2x minus 6 equals 3y. All I did was subtract 6 from each side. Now to get y by itself, divide both sides by 3. And that gives me the equation y equals 2x minus 6 over 3, which I could then write as f of x equals 2x minus 6 over 3. Now, because I was asked to evaluate f of -5, I will simply substitute in -5 where I have an x and clean this thing up. So 2 times -5 is -10. -10 minus 6 gives me a -16 in the numerator. My denominator is 3. And that does not reduce down. There are no common factors between 3 and 16. So that would be your answer in simplified fraction form, which is typically what we do. Don't change it to a mixed number unless you have been instructed to do so. Okay, we are almost through. We have one more page. And as we talk about functions that are increasing, decreasing, and constant, I often tell students This is sort of like pat your head, rub your belly at the same time. You've got to look at a graph and pay attention to what the y values are doing, but you answer the question using the x values. Here's what I mean. If you look at this example 9, what we have is something called a piecewise function. In other words, you can see pieces of graphs that have all been stuck together on one coordinate plane. And so there are 3 distinct sections. I'm going to call this one on the left section A, the one in the middle is section B, and the one on the right, we'll call it section C. And we're supposed to determine the intervals over which the function is increasing, decreasing, or constant. Now, this is the trick. If I'm looking for a section that's increasing, that means that I look at the graph moving from left to right. Okay? Always look at the graph going from left to right. As I do that, when I hit a piece of the graph, if it's increasing, it means that if I stay with my finger on that section of the graph, increasing would have to be moving up. But that's moving up as I'm going to the right. Okay? That means arrows have nothing to do with increasing or decreasing. So the fact that section A has an arrow and section C has an arrow tells me nothing except it keeps on going. It's not going to indicate anything about increasing or decreasing. So when I ask you to find the section of the graph that is increasing, there is only one section that as I'm moving from left to right, the piece is going up. And I hope that you recognize that that will be section C. Notice as I'm moving to the right, it's going up. Now, to identify the interval, we use the x values. So the very first x value in this piece that I would come to as I'm moving from the left has got to be this ordered pair right here, doesn't it? And that point is 2, -2. All right, that's where this piece would start, and then it continues going up as I move to the right. Now remember, we identify intervals of the domain which are increasing. That's why we're going to be using the x values. So we're watching the y's to see if they're going up, but our answer uses those x values. And this graph increases starting at what x value? +2. And because it's a closed circle on the graph, that tells me to use a bracket. And it continues to increase going on forever to the right. So it will increase all the way to +infinity. Not because it's pointing up, but because it continues to move to the right. So section C was the interval that was increasing. Now, to find a section that is decreasing, it means as I'm moving from left to right, when I hit the graph, my finger would be moving down. Do you see where that occurs? Well, I hope you recognize that it is section A. As you move across from left to right, this piece of the graph decreases, it goes down. Now, in order to answer what's the interval that's decreasing, again, now that I've identified which one it is, I'm answering it using x values. So notice that even though this has an arrow here, it's not that I'm looking that the arrow is going up, but when I'm thinking in terms of domain, in terms of x values, this thing continues to move to the left. What would be the smallest x value that I would have on this section of the graph? Well, it starts at -infinity because it keeps going forever to the left. And this thing is continuing to decrease until we get to this point down here. Now, what is the x value that goes with that point? Well, it is -2. It's not the y value we're looking at, although it does happen to be -2 as well, but it's the x value that goes with that. Now, does that need a parentheses or a bracket? Hopefully you recognize because of the open circle, we need a parentheses. So it decreases from -infinity to -2. Now, a constant section simply means it's not going up or down. It's going to be a horizontal piece. Obviously, that one's going to have to be section B. that is constant. By the way, if you're asked to identify this in a graph, it's not required that you have all of these pieces decreasing, increasing, and constant in the same graph. You may not have all three of these in the same graph. This one just happens to have it. And if I'm identifying the section that's constant, which we said would have to be section B, using my x values, it starts at -2 and it stays constant all the way through +2. Now I've got to put the correct end symbols on it. At -2, it's a closed circle. That's a bracket. But at +2, it's an open circle, and that's a parentheses. You'll need to practice that a little bit to get confident. Now, the last question is letting us interpret a graph that would have these increasing, decreasing, and constant questions. So this is to represent the number of gallons in a small swimming pool over a period of time in hours. So notice the x-axis represents hours. It's using the variable t. The y-axis would be the number of gallons that are in the pool over that period of time. So question A says, over what period of time is the water level changing most rapidly? Well, where does it look like it's either going up the most or down the most? That would have to be this first section right here, because that's the steepest section of line. It's either going up or down the fastest there. And if we were to give the interval of time where it's changing most rapidly, again, we're going to have to use the x-axis values, and that would be from 0 to 25. Now, the next question says, after how many hours does the water level start to decrease? In other words, where is the first place on the graph that the graph would begin to go down? And that occurs right here. The x value that goes with that is 50. So after 50 hours, that's when the water level decreases. Last question, how many gallons of water are in the pool after 75 hours? Well, if I track up from 75, what I should see is the y value that corresponds to that would be 2,000 gallons.